You've been following a Bitcoin transaction and suddenly you run into something a little odd on blockchain.com. This transaction only has one input but three outputs, and one of those outputs is labeled as unknown. So what does this actually mean? When a Bitcoin transaction output is marked as unknown, it means there's some extra data attached to it. That extra data is stored in something called OP return. OP returns allows a transaction to carry arbitrary information. It could be a short string, a piece of text, or some encoded value. And as it happens, blockchain.com conveniently decodes that OP return for us right here on the left side. Let's unpack what we see. The first two values are ETH and USDT, followed by what looks like an Ethereum address. Then there's another value that could be a memo or identifier. And that last piece, we'll come back to it. For now, what's clear is that the address ending with GEE sent about 0.013 Bitcoin, roughly $1,500 to another Bitcoin address. That's not a change output either, because the amount is a nice round figure. Alright, let's switch over to mempool.space and take a look at the same transaction there. Here, we can immediately see that an OP return payload is included. And this time, it's clearly shown as part of the transaction output rather than being hidden behind an unknown label. So what's really going on here? This is where THORchain comes into play. You might remember from earlier lectures that THORchain is a decentralized cross-chain liquidity pool. It allows users to swap native assets, like real Bitcoin, for real Ethereum-based tokens, without wrapping them or going through centralized exchanges. To make these cross-chain swaps work, THORchain needs to attach tracking data to each transaction. That's what this OP return message does. It encodes details like the destination blockchain, the token being swapped, the target address, and a few other identifiers that link this Bitcoin transaction to the THORchain network. Let's grab the Bitcoin transaction hash and drop it into the THORchain Explorer you'll find on this website. And here it is. We found the actual swap. It was executed using SwapKit, which is a development toolkit built by THORSwap. SwapKit basically allows any wallet or decentralized exchange to connect directly to THORchain's liquidity network. Different front ends use it in the background to route swaps between chains. In this case, the swap came from the Ledger wallet interface. The inbound side shows that 0.013 Bitcoin was sent to our THORchain address, just as we saw on blockchain.com. On the other side, the outbound section shows 1,400 USDT being sent on the Ethereum blockchain. If we expand the tabs below, we can see even more details. The input address, the originating transaction hash, and within the swap section, things like the timestamp, the conversion rate, and the fees. THORchain handles all of this internally using its own token, Rune, as a settlement asset between different blockchains. A bit further down we can even see the memo. That's the same OP return data from the Bitcoin transaction. And in the outbound section, we have the destination address and the transaction hash that completes the swap. Now let's head over to Etherscan and take a look at the other side of this process. The transaction action shows a transfer of 1,400 USDT to the address ending with A66. Here, we get much more detailed information than we do on the Bitcoin side. The sender in this case isn't the user. It's a THORchain controlled address and interacts with the THORchain router contract. Scrolling down, we can see the ERC20 transfer of USDT, and if we click Decode Input Data, we can read everything clearly: the destination address, the amount, and the memo itself. The memo directly references the Bitcoin transaction we analyzed earlier. This confirms that the Ethereum transaction we're looking at is the final output of that same cross-chain swap. That's pretty neat, right? Now let's go a bit further and look at another case, this time involving Ethereum and Litecoin. Here's a transaction on Etherscan that shows a swap of 90,000 USDC through THORchain. We'll go straight to the Details tab again and decode the input data. Once we do, we see the familiar memo, which contains the information about the swap. This time though, the funds are heading to the Litecoin blockchain. We can tell from the Litecoin address included in the memo. Let's copy the transaction hash and plug it into the THORchain Explorer. There it is again. Another swap. Also done using SwapKit, but this time directly through THORSwap. On the left side, we have the 90,000 USDC coming from Ethereum, and on the right side, 852 Litecoin being sent out to the Litecoin network. Just like before, the expandable tabs show all the details: the inbound transaction, the swap specifics, and the outbound transaction. You can open the destination address directly through THORchain Explorer, which links to blockchain.com, or copy the transaction hash and view it in litecoinspace.org for another perspective. On Litecoinspace, we can see that the input address, which is controlled by THORchain, received about 6,000 Litecoin. Of that amount, 852 were sent to the user, and the rest went back as changed to the same THORchain address. Litecoin transactions, just like Bitcoin, also include OP return field, and in this case, it holds the transaction hash of the original Ethereum USDC transaction. To summarize, you've seen how OP return fields carry the metadata that links transactions across chains, and how THORchain swap mechanisms connect entirely different blockchains together without centralized bridges. See you in the next lecture.